Welcome everyone. Let's discuss another question from GATE 2024 Biotech exam. The question says, the free energy change of ATP hydrolysis at 25 degrees Celsius is minus 32.2 kilojoule per mole. The free energy change for hydrolysis of alpha-glycerophosphate to glycerol is minus 8.2 kilojoule per mole at 25 degrees Celsius. Using the above information, we need to calculate the free energy change for the formation of alpha-glycerophosphate from glycerol and ATP, and we need to report our answer in integer. So, if we can write these equations, the first reaction is ATP hydrolysis, and the hydrolysis of ATP will generate the adenosine diphosphate and inorganic phosphate and some form of energy. And the free energy change for this reaction is minus 32.2 kilojoule per mole. The second reaction is hydrolysis of alpha glycerophosphate, and it's also a hydrolysis reaction. And the free energy change for this reaction is delta G value is minus 8.2, both is in a kilojoule per mole. Now, what we need to do is, with the help of these values, with these information, I need to calculate the free energy change for the formation of alpha-glycerophosphate from glycerol and ATP. So I need to calculate the formation of alpha-glycerophosphate from glycerol and ATP. ADP plus PI will come this side because I'm making use of a ATP. So I'm generating alpha-glycerophosphate with the help of the ATP. If you can look at the above equations, the first equation, the ATP is coming on the left-hand side, and so in the overall reaction. So that should be fine. However, in the second reaction, the value of delta G is for this particular reaction is, that is, the conversion of the glycerophosphate to the glycerol is minus 8.2. However, in the overall reaction, they have asked to form alpha-glycerophosphate. So this, when I'm comparing this overall equation with the second one, in terms of the glycerol and glycerophosphate, the reaction seems to move in a reverse direction. And that's the reason what we'll do is, for the overall reaction, we'll consider this delta G value as plus 8.2. So what I'm trying to tell you is, you have the same first reaction and then the second reaction. What I've done here is, I have reversed the second reaction. So initially it was the formation of the glycerol. Now I have changed it to the formation of a glycerophosphate, because if you look at the overall reaction, only then this condition will give you the formation of the alpha-glycerophosphate from the glycerol and ATP, because these are the two individual free energy change for these reactions, and if I'll combine them, I'll get this particular reaction. So keeping all these things in mind, what I need to do is, I can calculate the free energy change for this final reaction, which I'm calling it as third, and the value is going to be the sum of the individual delta G values, which is minus 32.2 plus 8.2 kilojoule per mole, and the value is going to be minus 24 kilojoule per mole. So this is going to be the final answer. Also have a look here. For the first reaction, the value of delta G is negative, which suggests you that the reaction is spontaneous and it can easily move in the forward direction. However, for the second reaction, when I have reversed it, the delta G value is positive. Seems it is non-spontaneous. However, this reaction is happening. Why? Because I have combined the second reaction with the first one. And this first reaction is facilitating the formation of alpha-glycerophosphate. Such reactions are also called as coupled reactions, where I have coupled the two reactions to facilitate the conversion of the glycerol to the glycerophosphate. So coming back to this question, you need to report your answer in the form of integer. So the final answer is -24. I hope this solution is clear to each and every one of you. If not, please feel free to comment in the comment section. Thanks for watching the video.